Hello, Professor. Actually, I have a question.
3 more minutes and we'll be starting from 6. Okay, 6 p.m. Let's get started. Uh, so, Omid, do you have some question for me?
Yeah, just I wanna ask you, can you put your lecture 7, because you put your lecture until lecture 6, you put it on YouTube, and I cannot save the your video on Canvas, but I can save it on YouTube. Can you put your lecture from lecture 7 until the end of the lectures on a YouTube? Can you post it?
Sure, yeah, if I get time, but you can access that lecture from the Canvas, right?
Yeah, yeah. I want to save the video because I review every time, Sometimes I review the video and it's so hard on a canvas and I cannot save it. But on YouTube, very easy to get access to the video on a YouTube.
Okay, okay, sure. Yeah, I need to find some time to upload them.
Okay, thank you so
I
much.
was diligently uploading them for the Open University student who didn't have Canvas at that point. But right now, I'm assuming all you have the Canvas and video accesses, so I'm kind of not actively uploading them. So basically, if I get some time, I'll definitely load.
Okay, thank you so much. Thank you.
So is there any other question? So we have 30.
Professor, what is the use of the load upper immediate instruction?
Use of load upper immediate. Yeah, so that is a good question. Load upper immediate is letting you load some values to the higher bytes of the memory or higher bytes of the register, I would say. Why don't I just explain it over my Jamboard? Just let's see. No, where is my Jamboard? Oh, there. Okay. So you have these why it is not responding? Sorry, some technical glitch. Okay, now it's working. Okay, so you have these 32 bits, right? This any register operations of 32 bits. So you can divide it into 16 bit each. So let's call this is the upper half, upper portion, and this is the lower portion, right? Now the question is how to load a value into these 32 bit together, like 32 bit value, how to load, right? So basically, if you look at any immediate operation, like add I, something like that, let's say you are loading onto register 2, and this one is a constant, constant 0 always, $0 is constant 0 always, and you supply some value here. Let's say you are supplying some value in terms of your in terms of hex format. Let's say 0x stands for hex. Let's say some value 1 2 3 a, some value. Now what the limit of this value? What is the limit? Since the add I is immediate instruction, it holds like this, right? Opcode, then RS, RT, then immediate. So this is 6-bit, 5-bit, 5-bit. So that means this is 16-bit. So that means this value, immediate value, is bounded by 16-bit representation. So you cannot go beyond that value, right? That means you can only fill up or like fill up these bit patterns on the lower 16-bit part. What would happen to the upper one? How shall we do that? Definitely you can say that, hey, I load this in the lower bit and do a shift left logical on the lower 2 by maybe 16-bit. So this is like $2 equals $2 left shift by 16-bit, so that we pick this half and copied into this part, right? That one way to do, right? But MIPS provides this load upper immediate LUI to do that purpose, exactly that purpose. So load upper immediate $2 123A, what it will do, it will basically load this exact 16-bit pattern of 1, 2, 3A onto the upper half, leaving the lower half as 0. Lower half as 0. So either you can do this combination of the instruction or use one-shot instruction to the mix. That is one thing. Another thing is now where it is used. So usually, sometimes you need to load register with memory address, like a string address, which is like you refer in the assembly program as a label, but at the end of the day, assembler change it to some memory address and it need to place it on the 32-bit register. This is 32-bit value, right? This memory address. And that point, assembler uses one instruction to load that memory onto the upper half, and rest of the bit, it use something like or I $2, let's say you do something like this, 50AB. After that, or in terms of here, if you do or I $2, 50AB, so it will basically perform an OR operation between these 16-bit value with this 32-bit value with 0 extended this 16-bit value, and ultimately the result would be it will place the this new lower bit value into the lower half, 50AB. So what these two together does is load the some value like 123A 50AB into the register, target register, and which could be a memory address to operate on and to refer to the latter point of time. Make sense, Carter?
Yeah, so essentially it just allows for more operations to occur.
Right. So
as in you can save more information to the register.
Exactly, and you save basically one extra instruction. You can still do this, like you load the lower part through some add I or load immediate pseudo instruction if you want to use that, and then left shift that bit pattern onto the upper half, and then perform the ORI operation. So instead of running 3, you basically can use it via 2. Basically, you are optimizing on your program.
I see. Thank you.
All right. Any other question on this or any other from the previous lectures, logistics? Yeah, I just saw that they're still on the waiting room. Yeah, while so my waiting room is on. So basically for those who joining late, please make sure to join 5 minutes early. I open up this meeting 15 minutes before the class time. Please join it. Otherwise, we probably can miss some part while discussion. When I am discussing something, I don't usually look at the like waiting room. But as soon as I see, I admit you and make you enter in the classroom. Okay. So today we were supposed to discuss about this or study about this memory usage model, like we have like three part of it, 1, 2, and 3. This first part is really easy. It is kind of an how do you manipulate the register file and each individual register in the context in the MIPS register file content. And there are only handful of instructions there. You can directly manipulate the register value. One of them you are probably using it, but that is a pseudo instruction called load immediate values. There is load address and so on and so forth. They are all pseudo instruction. And these register are manipulated by these register type instruction, immediate type instruction. All of them basically stored their result back into the register. So all of them are manipulative instruction for the registers. I would like to share these specific one specific point about the usage of the register in the class. Let me share that first. All right, so, oh, wait a minute, just hold on. Okay, share. I hope you have seen this slide already. So this one is basically telling you that there are these 32 registers, each of them 32-bit, and there are this number, you can refer them by the number like $0, $1, $2, etc. Like in the successive experiment, probably you have seen that doing it. Or you can refer them in your program by their name, like $0, $80, etc., etc. And they have been given name to for a easy, so that you can easily remember their purpose. So each of them has a purpose. Just to be clear on this point, that these purpose are really a software convention. Like when you write a program, you use those register for some specific purpose from software convention point of view. You can use any register at any point of time for any purpose. There is no, like at least from the hardware perspective, there is no restriction except for the $0. Except for the $0. $0, even if you want to store something, write something to it, system would let you do. Basically, the hardware prevents you to write anything. This register serves as a constant 0 for your program if you want to use it. But other than that, any other register, AT, V0, A0, you can use at any point of time. Okay. Only this table tell you the software convention, what they are used for, so that if you go out of the convention, you may get into trouble. Because your program is also functioning with respect to or including the others program as well, at least the system level programs that Mars IDE provides for your system call and etc. etc. The pseudo instruction support, those kind of things, you will be messing up with that thing. Okay, so for example, $80 is an assembler temporary, and that's why you should not use it in your program. Because whenever you use a pseudo instruction, it is highly likely assembler will replace your instruction with a bunch of basic instruction using $80. So that means if you are storing some value at this $80, it might get overridden by the assembler instruction at some point of time. So it is risky to use. Similar convention is for the V0, V1. They are by convention used for value return from the function when we implement the function. So this one is probably won't make sense right now to you because we don't know how to write a function in the assembly, function in the sense of function. Like it is not, don't think about the high level function or that kind of thing here. It's more like a low level function, how we can make them on the assembly. Okay. So we'll have one full lecture about the function implementation at the assembly level, and we'll talk about that at that point. But right now, you just learn the convention that if you write assembly level function, the convention is that return values are through this register V0 V1. That is purely convention. Okay. Similarly, the arguments are passed into the function through A0 and A3. Okay, and then temporaries are basically the temporary values which are not preserved across a function call. So all this, most of this, like usage model are with respect to the procedure call or function call. Okay, so when we learn about the function call, probably it will get more, it will get clearer basically at that point of time. But right now, what we are trying to learn that our usage of this register and somewhat with respect to the function calls, and let's assume there is a function call in future. Okay, so A0, A3 is argument, and T0, T7 and T8, T9, they are called temporaries because of the fact that it is not guaranteed that if you call a function, the value within T0 to T7, these registers, and T8, T9, these 10 register, temporary register, the value will be preserved. It may happen that function that you are calling can override the values onto the T0, so or temporary register. So that means if you are going to call a function and if you store something on the temporary register, assuming that will be preserved after the function call is done, that control comes back to your routine, you may be wrong, right? You may be wrong. For that purpose, we have this saved temporaries, S0 to S7. So it is guaranteed that if you store values under this S register, S0 to S8, by convention, function will not override this register. Okay, it is guaranteed that when the function call is done and you get result from the function, your S0 to S7 content will remain intact. That is the convention. All right. Similar convention on K0, K1, these two registers are reserved for the operating system kernel. For you in our environment, it is the Mars system that use this K0, K1. So better you don't use it. Okay. And similarly for the global pointer, stack pointer, frame pointer, and return address, you can manipulate them at your own risk, but they have a special purpose in hand. For example, global pointer always points to the the dynamic part of the memory, the heap. Stack pointer supposed to always point to the top of the stack. Frame pointer, we'll talk about that again when we are talking about the function implementation in the assembly, but it has to point to the latest start of the frame for that procedure. And return address always store where to return back after the function is done. Okay, so don't mess up with these register at all, GP, SP, FP, RA. And one more thing I would like you to pay attention to, this argument register usage. You'll see in the cheat sheet that has been given for in your MIPS book on the first page, it says that this argument is not preserved across the function call. That means function can override these arguments, but in this class assumption is that it has to be preserved. Okay, this is our class assumption. Please make sure you note this. Otherwise, all your programming assignment, it will get complicated and you will work on top of my existing code. And also on the project, you will work on top of my existing code. And all this code assumes that argument passed into the function are not overridden. They actually preserved across the call. That is our assumption. If you don't follow that assumption, you'll possibly run into trouble. Okay, so this is the one deviates from the book's assumption. Question.
Is there a particular reason why T8 and T9 are separated from the others?
That's a very good question. I never thought of that. Let me think. Okay, I'll get back to you. Can you please put your question on the discussion? This is very interesting discussion.
Okay.
It's purely maybe arbitrary, maybe. Maybe they wanted to have some like 8 group of registers, like 8 temporary, 8 this thing, and they suddenly found that when designing, we have 2 extra registers, so it just assigned, okay, they're temporary. Yeah, but I'll find out. Maybe they have a reason. That's a good question.
I have a question.
Yes.
So, kind of about the writing the upper 16.
Matthew, your sound quality is really bad. Either maybe you want to type into the chat your question, or maybe you want to just speak up a little bit louder, or I don't know.
Can you hear me?
Yes, now it's better.
Oh, okay. So about this upper 16-bit value, oh, I'm sorry. I'll type it. I'm sorry.
No, we could hear you perfectly, Matthew.
I have background noise.
Oh, that's okay. We don't mind. Unless it is much.
So the upper 16-bit value and the when we do the LUI, we do LUI and then we do ORI. But does the if we switch the order, would we overwrite the ORI?
Yes, yes. LUI always overrides this lower bit and set to 0.
And the ORI will not overwrite the higher bits.
ORI is a 32-bit operation itself. So what happens? Let me explain that. Okay, just hold on. Where is my Jamboard? Here. Share. Okay, so what happens there? Okay, let's talk about these two, right? Louis. It's $2 and some 1, 2, 3A and or I $2 is some pattern 0x A528 something like that, right? So this guy will make a specific register. This is, let's say this is a $2 register. It will put that 16-bit value onto the higher bit and reset all the lower bits. Okay.
I don't see the screen. What are you on a different screen?
I'm sharing that. Are you guys seeing my Jamboard? Oh, sorry, my bad. Okay, it is in here. Thank you. Yeah.
Okay.
So in this example, the very first one, Louis, will store the 16-bit into the upper half and reset the lower bit, right? Now this function, ORI, what it will do, it will take this 16-bit value, okay, and make it a 32-bit value, which is like 0000 A528. That's what we called a 0 extension. It will do the 0 extension. And then it picks up this value, which is 32-bit, right? 0123A 0000, and then OR between this bit pattern. I'm not expanding the bit patterns for you, but if you OR logically OR them, you will get 123A A528 and that will be stored back into the A2, this register 2. So register 2 will now contain as if we are just inserting the lower half through this ORI, but in fact, ORI did is a 32-bit operation. Make sense, Matthew?
Yes.
Other questions?
Yes, Professor. In what cases would you use the save temporary registers over the temporary registers?
At some point of time, let's say you are writing a complex program and you want to save your information. You don't want to get it like overridden by function call with that, for that purpose.
Okay.
So it's basically, yeah, probably don't make sense right now. But once you start doing this complex programming, you will see you pretty much need save register, and sometimes you have to use them all practically to save. It depends on the what program you are writing practically.
Okay, thank you.
Yeah, so let's wait for the function that discussion to be done, and probably it will be clear at that point. Okay. So what else? Let me see. So let's see if you are ready or class preparedness. Let's take a poll around that. Let's take a minute. It's coming to you. We have 40 out of 43. Maybe I'll end the poll and share the result with you. So 56%, some of them you watched the video, 37%, all of you watched all the video, and lecture note wise, okay, reading is much better. 54% of you have read the topic lectures. That's good. Query wise, yeah, we have some discussion, seems like, okay. All right, next one. Please go to your Canvas, search your pop quiz, and let me know when you are ready to have the password, okay? So go to your Canvas, find the pop quiz 2, and click on that. It will get you into the some stage where it wants you to enter a passcode. That time I'll share it.
I see it's locked until 7:15 p.m.
Locked?
Yeah,
It
locked
says
till the
it's locked.
14th.
Yeah, so it's I guess locked since the 14th.
Yeah.
Oh, what date is today? Oh, 16th.
16th.
My bad, my bad. I thought today is 14th. Okay. Can you see it now?
Yeah. Yeah.
Let's see, 34 or 43 said yes, 37, 38. 39, 40, 3 more to be at that point where you want to enter the passcode. One more, 42 are ready.
Can you see the password?
Yeah, I will. Yeah, 43, all of you are ready. Now I'll send another poll which has a passcode, okay? So
Okay, okay, I see.
one.
Mhm.
Did you already send a poll?
Yeah.
I haven't gotten the
You
poll
don't
yet.
see it.
Yeah,
You
I
can't
got
see it.
no.
Oh, there we
there.
go. There
Now
it
it's
is.
there.
There it is.
The problem with this is you can't copy the text out of this, so I have to manually.
Yeah, my
Yeah, it is not that complicated code, I hope.
It's not that bad, but it's.
You know what I do? I just close my eye and type in something. Okay. I see students are getting.
Can you share one more time the passcode?
Okay.
I don't
So you
know.
don't see that? Or you hit yes already?
Yeah, I hit yes, and I said I saw the passcode, and I put the submit, so I cannot.
Okay, okay. I'm ending the poll and relaunch it. Okay. Relaunch. Now can you see?
Yeah.
few more minutes and it will be over for all of you, I think. Okay, I think many of you are done on the pop quiz. And let's take a break, 5 minutes, about 6:50. We'll be back. Okay, 6:51. Let's get back. So how was the assignment one, programming assignment one? Did everybody are done with that?
It's pretty easy.
Easy, right? Yeah. So initial couple of assignments are to season you for the complex program, and as it goes along, it will take exponential curve. So I'm warning you, like it will stay low and easy initial, and then it will zoom, go up the hard level, and project is probably the hardest one that we'll face in terms of assembly programming. So now maybe what we can do, we can look at, or you can look at programming assignment 2. Can you go to your Canvas page, find out programming assignment 2, and it has an introductory video for about 7 minutes, 8 minutes for that assignment. I would like you to go and listen to that video now, and then we'll have some breakout room so that you guys can discuss among yourselves about that problem of assignment 2.
Which number was that?
Programming assignment 2.
The video?
Yeah.
Right.
Or if it is clear from the description reading, that's also fine. I'll just probably after 5 minutes, I'll open up the breakout room for you guys to discuss that problem. I'm opening up the breakout room for 10 minutes for all of you. Just continue with the watching if you're not done yet, but then come back and join the breakout room to discuss the problem among yourselves.
Hi there, I apologize. I think I was kicked out of the meeting for some reason.
You're good.
Okay.
So
what study group you are in, Joshua?
Last time I think I was with Brandon Ong.
Yeah, it's the same Canvas study group, right? Can you find out?
Yeah, I can look it up really quickly. I'm in group 11, if that helps.
Yeah, so I'm sending you there.
Professor.
Hello.
I think I'm supposed to be in Jake's group and Harrison.
You are.
I didn't get an invitation for some reason.
Oh, Edward Fan?
Yeah.
Edward Fan. Why didn't you get invitation? You should be in room 9. I don't know how to do that. Okay, room 9 again. Okay. Are you sure you are not getting that breakout room invitation? No?
Yeah, I'm not seeing anything.
Okay, so let me actually, it says you didn't join. Edward Fan, right? So
yeah.
I'm moving you to some other room for time being. Maybe room 8. Let me see. Did you see the invitation?
Yeah, I do. All right, thank you.
Edward, I just moved you to room number 9, your original room. Richard, is there any reason that you didn't join your breakout room? Richard?
Hello?
Yeah, I think we're end of the breakout session, and in a couple of seconds it will be closed for all of you. Let other come back. So anyone wants to tell me about what you think about that assignment 2? Hard, easy, doable?
Straightforward.
Straightforward? Okay, good to know that. Yeah, you have. Yeah.
Sorry, I was gonna say I really like the breakout room because I like talking to people about like the concepts we've learned. So.
Yeah, that's good. Good to know. Yeah, I'll try to put more breakout room if possible, and also like since we made the study group on the Canvas side, just maybe that becomes your study groups, and you can discuss and arrange your own meetings and discuss over things. Yeah, I encourage that activities. That's the right way to. Yeah.
I have a question.
Yes, Harrison.
Are the people in the breakout rooms going to be different every time?
No, I have pre-assigned according to the study group.
Oh, okay.
Yeah.
So these are like the people for the rest of the semester.
Right.
Okay, got
it. At least till midterm. I don't know whether after midterm I'll change the group or not. I'm still thinking. But yeah. Yes, yeah. Some teachers said that that's really useful if you change the group, like permuted the group a little bit during the break, so that you expose to more people and more ideas. Yeah, it has a pros and cons. I'm still not sure what to do this time. This is the first time I am trying this study group approach for this course. So let's see how it works.
Yeah, I think it helps a lot.
Yeah, especially with this hard concept, you guys probably need to discuss more onto the study and study together before the class on that topic, so that you guys can clear up each other's doubt first. And yeah, that's the idea. Yeah, this let me share this quiz summary for today. Pop quiz is basically is this. I don't know which screen I'm sharing. Hey, okay. This one, share. Okay. Yeah. So, yeah, not a good one average wise, 66%. Highest score is 100%. That's good. Average time is about 8 minutes, but I see points all over the place to the class. So as a class, I'd advise you to put more steam onto the study and see these pop quiz doesn't even it doesn't even include like today's topic. It was about the past topics, but pop quiz ideally should be on this current topic. So even for that, it's not a good indication, 66%. So please make sure you do that study upfront and make a good result on this. So any question?
For one of the questions for the quiz, it said this string is terminated with a 0. I thought the terminating character is a \0.
\0 is a null character 0. But yeah, if you have a doubt, just why don't you screenshot and send me an email? I'll take a look.
Okay.
So any concern on your quiz point, and maybe it's a wrong answer or like wrong question kind of stuff, please send me an email. Okay, I'll take a look. So all right, then let's stop tonight and make sure you turn in the assignment 1, programming assignment 1 tonight, right? This is due tonight. Yeah, and then your second assignment is due on this Monday. All right, good night, everybody.